What we have to do is simplify rational expressions by adding and subtracting today. Okay, so just like yesterday, we need to state the excluded values and then we simplify the expression by adding or subtracting. So first off, I'm going to look at my expressions. I'm adding 2 over n plus 8 and 4 over n plus 1. So right now, I can see that my excluded values would be n cannot equal -8 or -1, since when I plug either one of those in, it's going to give me a 0 in the denominator, so I can't divide. And it's really important we do this at the beginning of our before we start simplifying, because sometimes your factors will cancel out at the end and then you kind of like lose that number. All right, so what I need to do is get a common denominator. So on the first fraction, the denominator has a factor of n plus 8, and the second fraction has a denominator of n plus 1. So to get a common denominator, I'm going to multiply the second fraction by n plus 8 over n plus 8, and the first fraction by n plus 1 over n plus 1. So a form of 1. Anything I multiply on the bottom, I'm going to have to multiply on the top. Next, I'm going to simplify the top of the fractions by distributing by multiplying the numerator, basically. Okay, so I get 2 times n plus 1 is 2n plus 2 over n plus 8 times n plus 1 plus 4n plus 32 over n plus 1 times n plus 8. Now I can combine these over my common denominator. So I have 2n plus 2 plus 4n plus 32 over n plus 8 times n plus 1. So I can smoosh the two fractions together. Now we're going to add the numerator. So combine like terms. So I'm going to add 2n and 4n and then 2 and 32. So I get 6n plus 34 over n plus 8 times n plus 1. Now, I think that this is going to be my answer, but what I have to do at the end is factor the numerator to see if anything cancels, and cancel if I can, okay? So I'm going to factor out a 2. So I'm going to a GCF of 2. So I end up in the numerator with 2 times 3n plus 17 over n plus 8 times n plus 1. I have nothing in the I have nothing that will cancel from the numerator and the denominator. So I have my answer is this. You can also, honestly, this second to last step is also a feasible answer. Okay. Where n cannot equal -8 or -1. And since nothing canceled, we can see still that we can't plug in an n value of -8 and -1, but sometimes when the factors cancel at the end, it's hard for us to see that we still can't plug in these numbers. So whatever numbers you had at the beginning that were excluded values, they're going to stay excluded values for the whole problem. Okay. All right, so the second one, 5 over n plus 5 plus 4n over 2n plus 6. So I'm going to get my excluded values. N cannot equal, let's see, for the first n plus 5 is equal to 0, so it would be -5. And then I'm going to set 2n plus 6 equal to 0 and solve for n. So I get 2n, subtract 6, and then divide by 2. So n cannot equal -3. Okay, these are my excluded values. And now let's get a common denominator. So I am going to multiply the first fraction by 2n plus 6. Anything I do to the denominator, I must do to the numerator. The second fraction, I'm going to multiply by n plus 5 to get a common denominator. So again, anything I do to the denominator, I am also going to do to the numerator. Okay, so now I distribute. I get 10n plus 30 over n plus 5 times 2n plus 6 plus, distribute in the second fraction, positive 4n times n is 4n squared, and positive 4n plus times 5 gives me positive 20n, all over 2n plus 6 times n plus 5. And you can put it in the other order if you want. All right, now I'm going to combine the numerators. So I'm going to end up with 4n squared plus 10 and 20 give me 30n plus a constant of 30 all over n plus 5 times 2n plus 6. And now I need to factor and try and cancel things. So in the numerator, I'm going to GCF out a 2. So I get 2n squared plus 15n plus 15 all over n plus 5 times 2n plus 6. And now I'm going to try and factor out the numerator using the big X. So 2 times 15 gives me 30, my A times my C, and my B value is also 15. Let's see, I have 1 and 30, that doesn't add to 15. I have 2 and 15, that doesn't add to 15. I have 3 and 10, that doesn't add to 15. And I have 5 and 6, that doesn't add to 15. So nothing, 2n squared plus 15n plus 15 is prime. So nothing is going to cancel in the numerator and the denominator. So I end up with this. And we need to say where n cannot equal -5 and -3, because those are my excluded values. All right, last one. I have x plus 1 over x minus 4 minus x plus 1 over x squared minus 7x plus 12. And so first I'm going to take the denominator here and factor it so that I can see what multiplies to give me x squared minus 7x plus 12. So 12 and -7. So that would be multiply -4 times -3 to multiply to 12 and add to -7. So I can just rewrite this as x plus 1 over x minus 4, and leave a little space, minus x plus 1 over x minus 4 times x minus 3. And I already see that the second fraction has so the second fraction has 2 factors, so 2 things I'm multiplying together. It's x minus 4 and x minus 3. The first fraction already has a factor of x minus 4, so I only need to multiply by the second factor from the second fraction of x minus 3. Okay, so anything I do to the denominator, I'm going to have to do to the numerator. Now I'm going to multiply out x times x gives me x squared. X times -3 is -3x. X times 1 is positive x. And 1 times -3 is -3. Okay, then I'm going to sub all over x minus 4 times x minus 3. I don't multiply out the denominator because at the end I have to test to see if factors are going to cancel, so I might as well just leave the denominator as factors. Okay, then we're subtracting x plus 1 all over x minus 4 times x minus 3. Okay, let's write this expression with a common denominator. So I have x minus 4 times x minus 3. Let's see, the first fraction gives me x squared minus 2x minus 3. The second fraction, I need to distribute the negative, so negative x minus 1. Combine my like terms, I get x squared minus 3x minus 4 all over x minus 4 times x minus 3. Now I need to factor the numerator. So I have a negative 4 on the top and negative 3 on the bottom. So I can multiply negative 4 and 1 to give me negative 4 and add to give me negative 3. So I end up with x minus 4 times x plus 1 all over x minus 4 times x minus 3. And ta-da! We have factors that cancel. So my simplified expression is x plus 1 over x minus 3. And if I didn't do it. This is a naughty on me. Okay, so I can see that from the second step, when the expression is in factored form, this is the easiest time for me to get my excluded values. So I can see that the denominators from my expression, my two fractions, will give me my excluded values. So I can see that x cannot equal 4 or 3. Okay. So when I go down to the bottom, I need to say x cannot equal 4 or 3. And because the x minus 4 canceled out, like I can't really tell from my answer that x can't equal 4. It's really the rule comes from the beginning of my equation or expression, expression. So my answer is x plus 1 over x minus 3, where x cannot equal 4 or 3.